Hello everyone, welcome back to my channel. In our previous video, we discussed what is an embedded system, difference between microprocessor and controller, and where embedded systems are used in real life. So if you haven't watched that video, I recommend you watch it first. In this video, we are going to understand basic building block of an embedded system. Think about a washing machine or automatic water pump. Inside that system, there is a small controller that takes input, processes it, and gives output. That full setup is an embedded system. Now let's understand this block diagram using real life examples. So it becomes very easy. Every embedded system works like a living person. First is power supply. Power supply means energy. Just like a human body needs food to stay active, likewise an embedded system needs power to work. If we do not eat food, our body becomes weak and stop working. In the same way, if power supply is not given, the embedded system will not work at all. So power supply is the basic requirement for any embedded system. Next is input. Input means information given to the system. For example, when we see something or hear something, that information goes to our brain. When someone calls your name, your ears receive that sound. That sound is input to your brain. Also in embedded system, switch press or sensor values acts as an input. So input tells the system what is happening. After receiving input, the controllers work like a brain. The brain understands the input and decides what action should be taken. Similarly, the controller processes the input based on the program stored inside it. Next is frequency generator. Now this block is called a frequency generator or clock. Clock means timing. In real life, our body works according to time. We eat at a fixed time, sleep at a fixed time, and attend classes at a fixed time. This timing keeps our life disciplined. In the same way, clock provides timing to the controller. It controls how fast the controller works and when each operation happens. Without clock, the system will not work properly. Finally, we have output. Output means result. In real life, after brain makes a decision, our body gives a response. For example, when you hear your name, you turn your head. That action is output. In embedded system, LED glowing, motor running, or display showing messages are examples of output. Now let's understand input and output more clearly using daily life examples. Input and output are present in almost everything we use. Input means anything that goes inside a system as information. Our eyes, ears, and skin continuously receive information. For example, when we see light, that light goes to our eyes. When we hear sound, that sound goes to our ears. This information is input to our brain. Input in embedded system. In embedded system, input can be given by switches or sensors. For example, temperature sensor gives temperature values. Button press gives command. So input is simply information coming into the system. After input is received, the controller processes this information, it checks the condition and decides what output should be given. Output means response of the system. In real life, after our brain understands information, our body gives a reaction. For example, when we see something hot, we move our hand away. That action is output. In embedded system, output can be LED turning on or off, motor starting or stopping, display showing information. Now understand what is inside the controller. Controller is like a small brain inside the embedded system. This brain has different parts, and each part has a specific role. First is ROM, read-only memory. ROM is the place where the instructions are stored. In real life, whatever we learn in school and college stays in our mind for a long time. That permanent knowledge helps us decide what to do. In the same way, ROM stores the program which tells the controller how the system should work. Even if power goes off, the program in ROM remains safe. Next is RAM, random access memory, also called temporary memory. RAM stores temporary information. For example, when we solve a math problem, we write rough work on a paper. That rough work is used only for that time. Similarly, RAM stores temporary data like sensor values and calculations. When power is removed, this data is erased. Next is ALU, Arithmetic Logic Unit. Now this part is called Calculation Unit. ALU is responsible for calculation and the decisions. For example, when we compare two numbers or calculate marks, our brain performs calculation. In the same way, ALU performs operations like addition, subtraction, and comparison inside the controller. Finally, we have the control unit. Control unit works like a manager. For example, a manager decides who will work, when the work will start, and in what order task will be done. Similarly, the control unit controls all operation inside the controller. It coordinates between ROM, RAM, and ALU. So output is what the system does after processing input. So this is the basic structure of an embedded system. We will understand everything slowly in upcoming videos. In the next video, we will learn another important concept. Thank you for watching and stay connected with channel.